All right, here we are in chapter 3. And I want you to make sure you've got your note sheet ready. And if you want a calculator, get your calculator ready. So pause the video if you need to and grab those materials. Alrighty. So at the top, it should say chapter 3, section 1, ordered pairs. And our learning target for today is this, I can. And this one's a little wordy, so make sure you pause the video if you need to. Okay. I can. Okay, and it's two-part. Write solutions of equations in two variables. Okay, and typically we'll have x and y. Okay, as ordered pairs. Okay, so you're going to write solutions of equations, two variables as ordered pairs. Now we've been practicing some work with our ordered pairs, and you saw that yesterday. Okay, so what we should probably talk about here is what again does it mean to have an ordered pair? Okay. All right. So first of all, let's talk about the pair part. Well, that means you have two numbers. They are coordinates. That's what we call them. We usually write them this way in parentheses. The first term is your x term, and these represent a specific spot on the coordinate plane. You've got to have the parentheses there because that's what tells you it's an actual coordinate on the ordered plane. If you just give me two numbers, it's just any two numbers, la-di-da. But you've got to have the parentheses around there. That's just a notation thing and one of those nitpicky math teacher things, okay? Have that there. Okay, two numbers, x and y, and they represent, and they're a coordinate, or in other words, a dot, or a location on the ordered, or on the coordinate system, on the system. Okay, it's a spot, it's a location. The order is important. You can't flip-flop them. That's a totally different place. Okay. All right, so here we go. Some of the first things you're going to be asked to do is you will be given an equation like 4x minus 1, and your job is to check, yes or no, whether or not these specific ordered pairs work. Remembering that the first one is x, the second one is y. The first one is x, the second one is y. So really what you're doing is you're substituting and evaluating to see if this works. So if I plug a 2 into 4 times 2 minus 1, your job is to say, does this in fact equal 4? Okay, because this is your x and this is your y. In fact, since I've got this in purple, I'm going to change to red. Okay, so we're testing a 2 and seeing if it works. Well, 4 times 2 is 8. 8 minus 1 is 7. That's not equal to 4. So this one is a no. 2 comma 4 doesn't work. 3, 3. Let's see if that works. So you have to take 4 times the x value minus 1. And our job is saying, does the y value 3, does that really equal this? Well, this is 12 minus 1, that's 11. Nope, that one doesn't work either. 1 comma 3, would that work? Plug 4 times 1 minus 1. Does that equal 3? Okay. 4 minus 1 is 3. Ding, ding, ding! Finally, yes, we've got one. Okay. Yes, it does work. Now the big question is, okay, so I tested these 3. I found one that worked. Can there be more than one solution that works? Can there be more than one that works? I'm going to tell you, actually, yes, there can be. And here's how you could find more. Let's take a look at the next example, which now this time they're using different letters, M's and N's, but that's okay. Here I'm giving you in the table that the M comes first and the N is the second one. So we're going to try what happens when M is 1. Okay, so you plug in a 1 here. You're saying, well, N is going to equal whatever 6 times 1 is minus 5. Let's see, that's 6 minus 5. That gives me 1. So my ordered pair is 1, 1. That's a solution. Can there be more than one? I'm saying yes, and here's how. Plug in a 2 for M. That gives me 12 minus 5. 12 minus 5 would be 7. Here's another solution, 2 comma 7. Plugging in a 3, 6 times 3 minus 5. Oops, parentheses, ma'am. That's 18 minus 5. That gives me 13. So 3 comma 13 is a solution. And frankly, we could go on forever if we wanted and come up with a list that really goes on forever of solutions that work. All right, so here are 3 that work. You'll do that skill as well. Then let's take a look at a word problem. It says a plumbing company charges $50 for a service call just to come to your house, and then $15 per hour. 15 bucks. That's cheap. Okay. They went on a 3-hour job. How much did the company earn? All right. So we're breaking this into a couple of steps here. First, let's write an equation to represent this situation. Okay. $50, $15 per the hours. Now they didn't tell us. They just want you to pick 2 variables. So kind of like at the end of the last chapter, you can choose letters that stand for what you want them to. Okay. Or you can just use X and Y. I think on your note sheet, I used X and Y and I said, X is going to be our input or the hours. And that means Y is going to be the money. Okay. All right. Well, we have to take 15 times the hours. So 15 times X. That's how much money they're going to get for their labor. And then $50 just for the service call. So that's where I'm coming up with this. All of this equals Y. Okay. Y equals all of this. So there's my equation. Boom. Make sure you've got that written down. Now, how much did they earn on that 3-hour job? Okay. I'm looking for my Y value. Y is the money. So you're going to say, well, I'm going to take 15 times the 3 hours and add 50. All right. Can you do this in your head? I bet you can. Who needs a stinking calculator? You have this calculator. Let's see. You get Y equals 95. Okay. This is a problem and of a real life situation. You need to label it. What is this? Hours or money? This 3 was the hours, so this must be the money. So they earned $95 for that 3-hour job. Boom. There you go. Then it says create a table to show the earnings for 2, 4, 6, or 8 hours worked. All right. So I think on your table, you've got your X values here that say 2, 4, 6, 8. Okay. All right. And that's our input here. And then we have the equation 15x plus 50. Okay. Then you'll have your output, the Y value, and then what our coordinates are. Okay. All right, here we go. So on this one, Y is going to equal 15 times 2 plus 50. Okay, let's see. 15 and 2 is 30. 30 and 50 is 80. 2 hours, $80. Plug in a 4, and you're going to do the same pattern again. 15 times 4 plus 50. 15 times 4 is 60, so I get 110. 4 hours, $110. 6 hours, 15 times 6 plus 50. That's 90 and 50. This is $140. So a 6-hour job generates $140 for the company. And last but not least, 15 times 8 plus 50. This is 80 and 40, 120, 120 and 50, 170. 8 comma 170. There's your table. So this is what you'll be getting used to. Plugging in these values, working with tables, ordered pairs, getting an equation, and doing a whole lot of evaluating. Alrighty? Your assignment then is to grab your workbook and open up to page 18 and do that for tomorrow. There you go. Good luck as always, and may the force be with you.